The future of conflicts is electronic warfare. The war of the future. Mastering the electromagnetic spectrum is fast becoming a priority area of future warfare, given the increasing degree to which networks and weapon systems rely on electronics. For example, a precision-guided weapon cannot reach its target if its radio frequency guidance is jammed or jammed by an EW. The Navy's 2024 budget documents reveal this emphasis by allocating large amounts of money to the spectral domain concerning the F/A-XX 6th generation stealth fighter. Navy and Air Force budget documents explain that lasers, EU weapons, and RF countermeasures are technologies that are expected to feature prominently in NGAD. An article in The Drive indicates that the Air Force budget request for the fiscal year 2024 calls for studies to develop operational system architectures that include a family (SIC) of spectral domain systems and platforms. Jam weapons and communications. EU applications are becoming more and more numerous due to rapid technological advances. Software systems based on artificial intelligence, for example, can help to deconfigure the spectrum by differentiating friendly frequencies from enemy ones and identifying which signals to interfere with. Spectrum information can be retrieved from a database to determine which signals to interfere with quickly. In addition, sensors and communication systems can be adapted to emit a more narrow or pencil-type electromagnetic signal. This is very important, as a larger or broader electronic signature can reveal the location of the enemy, while a more directed beam can produce an effect without emitting a large signature. Regarding weapon guidance systems, developers are working on frequency hopping technology to essentially counter an attempted electromagnetic interference. In the event that a frequency is jammed, weapon guidance systems can be set to hop from one frequency to another in order to maintain tracking or guidance to a target. Hardening networks, data links, or communication systems to operate in a jamming environment is critical to maintaining functionality in a contested EU environment. Sixth-generation fighters. In the case of sixth-generation aircraft, EU may prove critical in the field of manned-unmanned teams, since both the Navy and the Air Force plan to operate a family of systems, in which the aircraft of manned fighters control nearby drones from the cockpit. This can allow leading-edge drones to jam enemy air defenses, overwhelm communications, and share critical targeting information between formations. The passive EU can essentially listen to identify a line of bearing in an enemy electronic communication to locate signals to control or jam, while the active EU can issue a signature with jamming, jam, or jam communication. Platforms also increasingly use omnidirectional antennas to tailor an electronic signal in a specific direction and avoid emitting a large 360-degree signature that would be easier for an enemy to detect. Fighters and drones will operate together. For example, sixth-generation aircraft and the drones they network with can use SIGINT hardened or active data links to emit offensive-use EU signals and also harden the data links for more secure information exchange in a contested environment. These types of applications are central to the Navy and Air Force plans to create sixth-generation manned and unmanned teams called Combat Collaborative Aircraft, CCA. The concept is to network a family of systems together in real time using drones in close coordination with manned combat platforms to conduct advanced surveillance, check enemy defenses, ensure precision guidance, reinforce aiming sensors, or even throw weapons. Thanks for watching.